Hi, welcome to the new presentation on internal sizing of paper. I know this is a very sought after topic in the paper industry, and it has continued to puzzle the paper makers globally for a very long time now. So let us go through the presentation. This is just going to be a brief presentation, a brief introduction about the internal sizing of paper. Where internal sizing you think is used? It is used for wrapping up things, gift packing, or even these days you are buying lot of products from the e-commerce companies. If you order for a gift pack, it is wrapped in a particular paper and it is given. Bag paper. Lot of places we are using paper bags to carry lot of items. Many places to carry household goods, small paper bags are given by shops or retail malls so that it can be carried. Offset printing paper is used in the printing machine for offset printing purposes. Then you have food container paper, which is basically a product in which you keep food like paper plates, paper cups, right? These days, many food delivery applications, mobile applications are available wherein people order food in their residences and they can have it. Lot of places the food is carried using paper products. It is sealed and then it is given. Bond paper, writing and printing paper basically is used for mainly photocopying purposes, or maybe someone wants to take a print. He has scanned a document, he wants to take a print of it. Lot of places for leisure work, writing purposes, or drawing, mainly used for classes, basically for children to draw, calligraphy, or modern art. Everything, paper acts as a base on which the colors are drawn. Next is also chart paper, again used by students, artists, artisans, wherein they use this paper to create magnificent paintings, and it is loved by a lot of people. So these are the major applications of paper which require internal sizing. Now, why internal sizing? Because in all these applications, you need the paper should not absorb water beyond a particular point, or fluid, or oil, as per the case. For example, if you take food container paper, it should not be absorbing oil from the food and it should not spoil the food. For that, you need to do some internal sizing. Of course, I'll be telling in detail what the internal sizing is all about in separate set of videos, but the basic objective here one needs to understand is that paper needs to be sized. Sizing means control of absorption of any fluid. It can be liquid or it can be any fluid. So there should be a controlled absorption or total non-absorption. For example, if you want to wrap something in totally waterproof paper, you don't want it to say absorb water, right? It will spoil the items inside. So suppose for firecrackers is a very good example. You can't have material transporting firecrackers to get wet. They'll not get bursted. So you need to wrap it in a proper way so that the water is not absorbed. And this property of controlling water absorption is also managed by internal sizing. There are other ways of doing it also, but one of the major and most important methods is the internal sizing. So here are the few images of what we discussed earlier. You can see a paper bag or offset printing machine or paper cups. So the art paper, the decorative paper, mainly during festivals, we use all of these decorative paper to decorate our offices, decorate our residences, malls, shops, everywhere this is used. The major internal sizing agents are broadly classified in these three segments. First is rosin and alum. Now, the use of rosin and alum has reduced to a very large extent because of the inherent, you can say, disadvantages associated with this type of sizing agent. So, rosin combined with alum. Now, rosin also has types. You have got dispersed rosin also. But basically, I have categorized it as rosin and alum. It has to be combined together, okay, for the internal sizing to happen in paper. Second is AKD or alkyl ketene dimer. This is a product which is mainly used for alkaline sizing of paper when the paper has alkaline pH. So the pulp has alkaline. So during that time, you need to maintain the entire process alkaline. You need not make it acidic. Once you make the process acidic, there are chances that the system may get damaged. Then the third set is ASA, alkenyl succinic anhydride. That is the full form of ASA. Each of these sizing agents has their own set of advantages and disadvantages. But one needs to work out depending on what paper is produced. Different companies use different sizing agents, but in any one paper company, if a company is using, say for example, AKD, they will not use rosin and alum also, and they will not use ASA. They may have to convert it from, say, AKD to ASA or ASA to AKD, whatever it may be. But in a given paper, you can only have one internal sizing agent which is acting on it. That is the normal practice in the industry. Secondly, if you tend to add more agents into it, it will only increase the production cost, but the results may not be achieved. And why do we call it as internal sizing is because it is added at the pulp stage before the paper is made, in the wet section, in the pre-drying section, the wet section. So that is why it is said internal sizing, because it is added in the wet section, number one. Number two, it acts on the individual fibers. It acts at the individual fiber level. So fibers are formed into a sheet of paper. So it is basically covering the internal fibers. And that is why it is called as the internal sizing agent. I hope you have liked this presentation. For more such presentations, do log into this channel, subscribe, and learn more from the videos. Thank you so much.